Calculating the pH of 0.100 molar solution of propanoic acid. We're given the chemical formula of propanoic acid and the Ka value, noticing that we have two significant digits here. We have to set up the ice table because we are working with a weak acid, and it will establish an equilibrium with water. So we initially have 0.100 moles per liter of our propanoic acid, and we do not have any of its conjugate base or hydronium yet. There's a change that's happening to establish equilibrium, as denoted here, and we want to try to see if we can use the approximation method that will tell us about X if we can assume that it doesn't affect the initial concentration of our acid. So we take 0.1 and divide it by our Ka, and when we do that on our calculator, it is greater than 500, so our approximation method can be used in this example. All right, so at equilibrium, our concentration of propanoic acid is still 0.100. We have X and X as our equilibrium concentrations that we need to solve for. In order to solve for X, we need to write out our Ka expression. And we know that Ka is equal to our products, which is the conjugate base of propanoic acid and hydronium, all of this over the reactant of propanoic acid. Water is ignored because it is a pure substance. Now we can plug in our values here. So we have 1.3 times 10 to the negative 5 is equal to x squared divided by 0.100. In order to isolate for x, we're going to bring up and multiply both sides by 0.100. So we now have 0.100 times 1.3 times 10 to the negative 5, I'm just going to put a bracket here, is equal to x squared. In order to further isolate for x, we want to get rid of the squared function, so we're going to square root both sides. As such, when we solve this question, we get x. My pen is getting a little bit wonky, sorry about that. Let me just fix that. X is equal to 1.1 times 10 to the negative 3. Okay, so double check that on your calculator for yourself. I will do that as well. So 1.3 to the power of negative 5 times 0.1 and then the square root, we get 1.1 times 10 to the negative 3, and we responded with two significant digits here. Keep the full number on your calculator, but this is the significant digits that we're carrying through. So now we know the concentration of our conjugate base, and we know the concentration of our conjugate acid. So we can use the Henderson-Hasselbalch equation, times 10 to the negative 3 moles per liter. And the Henderson-Hasselbalch equation is pH is equal to pKa plus the log of our acid over our conjugate base. Conjugate base over the acid. All right. So we know the Ka value. In order to get the pKa value, we're going to apply negative log 1.3 times 10 to the negative 5 plus log of 1.1 times 10 to the negative 3 divided by 0.100. Sorry. Now we are going to do that calculation. So we have negative log 1.3 e negative 5. We get 4.89. So here we had two significant digits. When we put it into the logarithm, we get 2 decimal places. Now we're going to add it to the value of this right here. So we have 1.1 e negative 3 divided by 0.100. We're going to take the log of that, and we get negative 1.96. Again, we need 2 decimal places for each log. Now we're going to add 4.89 plus answer, and we get a final answer of 2.96 when we use the full number. So even though we know that we need 2 decimal places in the final answer, this is our final answer when we don't use the rounded versions. Okay? Thank you for watching.